So let's talk about artificial intelligence. My name is Andres Felipe Zapata Palacio. Right now, I'm connecting from Colombia, and I would describe myself as a professional that is motivated by projects that generate impact over communities and over quality of life of people. But which is the way? Of course, through technology and through education. In 2019, I had the big opportunity of doing my internship at SAMC. So I was not only a artificial intelligence researcher at RoboAI, but also a teacher for this artificial intelligence degree program that is at SAMCA. At the beginning of this year, I had to return to Colombia, but I continue working with FridAI. So today, I wanted to follow something that Peter mentioned at the beginning of the meeting, and is we should try to demystify, to take away that magic from artificial intelligence. And this is also the opportunity to introduce all of you to these two big areas of artificial intelligence, which are generative adversarial networks and natural language processing. But I'm not going to introduce you to these two fields from a technical or programmatic side. I'm going to introduce you in the concepts and in a more intuitive way, so that you can see that this is not just magic, and that actually we are capable to research, to create new tools around these fields. So before explaining how GANs work, let's see what they can do. So basically, a generative adversarial network is an AI that creates artificial realistic data. Let's see two examples. I want that my GAN generates realistic Pokemon designs. So what I should do is take all the available pixel art style drawings of Pokemon, and I make this artificial intelligence to read them several times. At the end, I expect that the machine is able to generate new designs of Pokemons. And what you are seeing in the screen is actually a real example, something that is available online, open source code, and that you can run, test, debug. So we can say that it is not perfect, but we see some general structure in the colors and in the shapes of these new designs. So we know that in some way this generative adversarial network is understanding the general structure of a Pokemon, and it's able to create new designs. The second example that I wanted to show is that it is not only asking the GAN to generate something, you can also give it some input. So this is a real example. Actually, you can find it in this paper in arXiv. And if you pass some basic drawing with some basic shapes of fashion cloth, it will be able to transform it into a realistic fashion design, as you can see there. So how is it possible that an artificial intelligence is able to make these things? So I think that in order to understand it better, we should take the name and decompose it into its different components. So generative, why is it generative? Because the objective is to generate artificial realistic data. Why network? Network because it is based on neural networks algorithms. And the keyword, adversarial. So actually, there is not only one neural network, one artificial intelligence. There are actually two artificial intelligence that are fighting each other in order to improve the generation. The best way to explain this generative process is with this example. So in this case, these two artificial intelligences that are fighting can assume some roles. So one can be a criminal and the other one can be a policeman. So what is the objective of them? The objective of the criminal in this case is to create realistic fake dollars. So it will create fake money, and it will try to pass the verification of people. It will try to trick people. In the other side, the policeman objective is to take money and check, validate if that money is real or is fake. So let's imagine that both start with some basic skills in their tasks. So not the policeman is expert, not the criminal is expert, but they start in a beginner level. So what we expect is that both are going to improve over time. At the beginning, this criminal is going to generate fake data with bad quality. It will be easily detectable by us as humans. So if we see the first example, we know as humans that that is not a real dollar, real $100. But over time, the criminal generates fake money, tries to trick the policeman, and the policeman give it some feedback. I detected this fake money or this past. So over time, when both are getting better and better in their responsibilities, what will happen is that the generated data will be so realistic, so similar to the real ones, that the policeman is unable to detect which dollars are real and which ones are generated. So we know something cool about these GANs is that as humans, we can be the policeman. So if we train a generative adversarial network, we can evaluate in a very intuitive way without having any knowledge. Any one of us could verify if an output of a generative adversarial network looks real or looks artificial. So one basic example is training a model that will generate handwritten digits. So you can see the process at the beginning is quite random, the generation, but after several iterations, it is going to take shape. It's going to learn that the numbers have certain form. And after many iterations, we can say that this is not beautiful, but almost recognizable. And it looks quite real. So this is something very passionate about GANs. Not only that they can create very incredible things, not only that they can replace in some points a human, but also that we can see the results and validate them in a very intuitive way. But I want to show you, before finishing this section of GANs, a more complex and more surprising example. You will see it, and then I will explain it to you. So what happened here in this video? You can see that at the beginning there is a photo. It is me and my girlfriend, and you can detect that there are two persons, there is a background, there is a river, there is a mountain. And at the end, what happens is that it looks like a Van Gogh picture. So this is what happened. This is a more complex example of GANs. Actually, there are two artificial intelligence that are fighting each other. One is trying to maintain as much information as possible from the beginning. So one is fighting for maintaining in the generated image, maintaining that there are two people, that there is a background, there is a sky. And the second one is fighting for putting all the artistic style, all the colors, the distribution of those colors over the image. And at the end, both are going to find a balance between content and artistic style. And that's what will happen at the end. This case is called a style transfer, and the code, of course, is available online and open source. So I invite you, if you are interested in these GANs, I invite you to check more about this. Now let's pass into the second section, the second big area in which I had the opportunity to research, to work, and to learn, and is natural language processing. But what is NLP? What is that? Basically, it's teaching machines to understand human language. Understand human language. Actually, human language is quite complex. It's ambiguous. You can say one thing, and two persons can understand something different from the same sentence. That's quite complex, but let's reduce that complexity now and see just a basic example. We have this sentence: Alex started working at Google in 2007. So we can, as humans, if we want to read, we know that English is not our native language. So what we do is that we go through the sentence and we try to understand each component and try to connect them. So if we start reading, we know Alex. Well, maybe Alex is a person, maybe Alex is a company, maybe Alex is a fruit. It's something, it's a noun. Start working, we know that those are verbs. At is a connector, in is a connector, Google is also a noun. We don't know yet. At the beginning, in the first analysis, we could say, well, Google can be a company, can be a university, can be even a person, can be called Google. And we see that this is a number, 2007. So that's the most basic example of natural language processing, understanding all the components of a sentence. But let's jump into something much complex, and is that we are going to identify, this is called name entity recognition. We are going to identify from those nouns what are them. So we know we can let's say understand that Alex started working. So if it started working, it's highly probable that it's a person. So Alex is my person. At Google, so if someone is started working at something, then we know that that is an organization, a company, and university. And we know that that number is not just any number, but it's a date that makes it explicitly which year, what's the beginning of that. But this is a very simple approach. Of course, in order to generate much complex models, we need other techniques, not just name entity recognition or post tagging. So the question is, in this moment, which is the state of art in natural language processing? Which is the model that obtained the highest performance, really understanding human language, not just processing, but understanding what it says and being able to answer questions. So this is the state of art. They are called transformers. They are based on deep neural networks. And what they do is that they are able to answer an English exam of reading comprehension. So all of us, in some moment of our lives, have presented an English exam. And in that English exam, one of the topics, of course, they evaluate communication, verbal communication, listening, reading, and writing. So this reading comprehension is actually a very good way to evaluate neural networks that work with NLP and to check if they really understand something from the human language. So what if we train an artificial intelligence with a text, and then we ask something, and we expect an answer? So we could expect two answers. Empty, if the answer cannot be delivered from the text, or the prediction, which is going to be some answer based on the text. So for this example, I want us to do the exercise. So here we have a text that talks about different types of rocks. Rocks can be grouped into three big categories: igneous, sedimentary, and metamorphic. And then what happened in the text is that it starts explaining each one of them, what is the process of transformation, of composition, and all that in the text. And then we are going to ask us these questions. An igneous rock is a rock that crystallizes from what? So we know that human language is complex and there can be many valid answers. We could say the answer is melt, magma, or lava. We could say just melt. We could say a complex, complete answer that will be rock crystallizes from melt. So there are many available, like very positive, good answers for that question. In this case, this transformer, which is called BERT, was able to predict that the answer was melt based on the text, based on all the words that were there. But something happens also. It is not perfect. And that's the direction in which natural language processing is growing. And it's validating that models are really understanding the text. So if we ask, how is a rock lithified? This is a question that cannot be answered from the information in the text. Maybe if we were a geologist and we were reading that, if someone asks us that question, we are going to answer correctly maybe, but not because of the text, because our previous knowledge. So in this case, this model tries to give a correct prediction. It tries to answer, but it does in a bad way. It says, how is a rock lithified? And the answer is into a sedimentary rock. That's not the answer. That would be a correct answer if we ask, a rock is lithified into what? Then that would be it, but it is not explaining how that happens. So natural language processing is still growing. Of course, this is not the only way to focus. This is question answering. There can be many other fields like sentimental analysis, but in this case, there is still too much to research, too much to create, and too much to improve, so that in some moment we can say that the machine is much better than us solving an English exam. So taking everything together, we saw the GANs, which were able to generate really good realistic data. And in the case of a style transfer, it is able to do something that looks like made by a professional artist with too much creativity, and it looks really, really, really beautiful. And now a machine is able to do that, in some way understanding both the content and the artistic style of the image. And in the natural language processing, there is still a big work to move in research and in new tools, so that in some moment we could communicate with them and we couldn't recognize if those are persons or not. So a bright future is beyond us. Thank you.
Can you hear that, Andres? Good.
Yes.
Good. We have a space for some questions, ask and beer section. And there's first one in the chat from Harri Suominen, and it's not necessarily related to directly to the presentation, but I'll ask it anyway from the people here. Would some of the students be interested to do a short interview about experiences in studying with SAMK and AI? No.
No, we're about to do that right now, right?
No, but interview. He's asking for an interview. It's a separate thing, I think.
But after presentation. At some point.
At some point. In general. In general.
Yeah.
Yeah. Yeah.
Yes, it's possible, but remember that I would answer from my side. I was a teacher, so I would answer from the teacher side. Yes, but of course, yes.
Good, good. I think we can arrange that. Yes. Good. Questions related to presentation, please.
Yeah, it's me, I guess.
No, questions from Andres. For the beer, so you can have more of it.
I got one actually.
Yeah.
If I send my selfie, could he turn it into a mom and pop picture? Like, if I send him a picture of myself, could you just turn it into one cup, like art piece quickly?
Can you hear it? I can repeat.
I listened to half of the question. If he sent an image, if I didn't listen the rest.
Yeah, if he would send you his image, his picture, would you be able to do that Van Gogh art thing with his picture?
Okay. That I wrote that code 2 years ago. Maybe it is lost somewhere, but I invite you to follow to do it by yourself. It is not that scary as you can think. And actually, I invite you, instead of sending me, in that hypothetical case, sending me the image, I invite you to do it by yourself. And I know that you are going to do it.
Wow, okay. Yeah. Good. Good. Okay, so we'll all be artists with your help, right?
So even better.
Even better, yes. Other questions? Jussi here has one.
Wait a second.
Yeah, so my question pertains to the copyrights and legal stuff of these. So kind of let's imagine that an AI creates a piece of art. To whom belong the copyrights? Like, is it you, the developer, who wrote the underlying code, or me, the guy who uses your code on my own computer to generate it? And what's preventing me from churning out like a gazillion different art pieces and just filing copyright infringement suits from here until the cows come home?
Okay, interesting. Okay, so how would I answer that? There are different licenses available for code. So you can have copyright over your code. You can protect your IP against people that you don't want to use it. But most of this code in artificial intelligence is open source. You can find the paper published online for free, in which they describe exactly which were the steps, which was the mathematical function, which is the algorithm, and they provide the baseline, the code, the base code, okay? So in those cases in which the project, in this case, I think that this code would be open because it is available, and I think that the code is open source. So but actually, if it wasn't open source, you can implement it by yourself. And then in that moment, that code belongs to you. And then you decide what you want to do with that. But let's say that it is open source. So if it's open source, anyone can open it, remove things, add things without explaining anyone what happened. And you can use it to create money or not. So depending on the open source license, if it's a GNU, or if it's Apache, or if it's MIT, depending on that, you can monetize that, or you cannot, or you can create money from that code, or you cannot. But in most cases, you can, because this code is open source. It's totally open source.
Good. Did that answer your question?
I think the question is highly important because, thanks, Andres. Yeah, I agree. It's easy when it's hardly here once again. Yeah, so it's like that when it comes to code. But I think you mentioned in your original question that what about the piece of art, or is it piece of art, and what exactly it is? Because code generates it based on your seed images, and what is the output? And I think that's highly interesting because I don't know. And I think the answer is different if we ask it in EU, United States, or in some other part of the world. It might be different. Yeah. So it's highly challenging.
Exactly, and I know a fair bit about US copywriting, about especially for thinking music, and there you can very easily farm money for just creating very simple jingles and kind of pointing that, hey, I created this piece all the way in 2010.
Yeah. Yeah, you're absolutely right. This is interesting and challenging topics. I'm confident we can't have black and white answer today.
Yeah.
But I think that now I have something more to answer, and is that I remember those words of Harry Ketamo that said that these are just tools. So in that case, I think that using this, like executing this from the command line and passing the image and then the output, it would be very similar if you think it as a Photoshop or another Illustrator tool. So I would say that if you create something in Illustrator maybe or in Photoshop, you are not doing bit by bit the transformation. You can apply filters and it will do it by yourself. So you cannot say that the generated image belongs to Photoshop. Of course, it's just a tool. So I would think that in the same way, this artificial intelligence model is just another tool that is a black box. You put something, it delivers you something, and you don't know what is happening in the middle, but you know that that tool is yours. So I would say that from that perspective, that belongs to you, and that's just a tool that you are using.
Very good.
Thanks.
Very good. Thank you. There's one more question from here.
But can I feed a model all the Disney cartoons and then set up an art gallery with those pictures that it generated from the Disney cartoons? Like, is it?
Kati, could you repeat me, please?
Say again, I wasn't.
So if I created a model like that creates cartoons and fed it all the Disney cartoons, can I set up an art gallery with those cartoons that it created that are very similar to the Disney ones, but are not the Disney ones?
But in that case, that data, but let's say that that's a very specific case and that data maybe doesn't belong to you. So it actually, I think that everything in Disney is protected against that kind of things. So if in some way you use that data and the copyright said that you cannot distribute or use this data without authorization, and you actually are doing that, of course there is a hypothetical case, and is that you are part of an artificial intelligence team at Disney. Then you are able to use that data. But if you do it by yourself, maybe that's illegal. So that's something important to take into account.
So I think that the point here is we can use the tool, no, in this case the GAN, but we cannot use the image. For example, the same as Pixar or Disney image, if they have copyright, we cannot use. And if not, if it don't have copyright, we can use, I think, the output image and put wherever license we want. No?
Yes, exactly. The point there is the data also is protected, not only the algorithm or the software, but also the data. So there are like two things, yes. It's correct.
Very good. There's one comment here in the chat from Pori from Tampere that someone asked that how to make AI picture. Please try this one. There's a link for you, so you can try the AI picture for yourself. So we'll share the link.
Thank you.
Yeah. How cool. Okay.
Thank you.
I think we have time for one more question if somebody has one. Or if not, then we can prepare for the students to have their own presentation and have a 5-minute break again to get everything set up and then continue. Thank you so much, Andres, for this and regards to Colombia.